it's not. People are thinking, my colleagues, and they're talking about an abstract images and things like that. So wait a minute, this is a science building. You got to put periodic table in there. So we want you to understand the organization of the periodic table. And that's another objective that we want to achieve here in this particular lecture activity. And now, talking about the formula of a compound and symbol of an element, you have to know a compound has two or more different elements chemically bounded together. So you use the chemical symbol of each element to represent, put that much, to represent the compound there. So you can write out what we call a chemical formula for a compound. The symbol of the element, that's for each individual element. So this is something that we will look at in the next learning objective. And talking about the chemical symbol. Now, when we look at the periodic table, when you see copper, we don't put the word copper in there, we use the symbol Cu. Magnesium, Mg, and aluminum, Al, okay, sulfur, S. So those are the symbols that we use to represent different elements there. And some of them are coming from the English language. Some of them were actually from Latin. So, and this is what a periodic table will look like. And different elements are in different physical states. Some of them are liquid, some of them are gas, some of them are solid. Okay, so, and there are 118 known elements. We put them in the periodic table. About 95 of them are naturally occurring. Some of them are actually man-made elements there. Now, we know, as I said at the beginning of the class there, is that if you're a magician, you can actually take protons, neutrons, electrons, and mix them together, shake in a bottle, and put them in a bottle and shake it, you get elements there. Not exactly how people created the new elements, man-made elements there, but in a sense. As long as you can manipulate the total number of protons, electrons, and neutrons, and you may, in a sense, end up with different elements. That's something that may not even occur naturally. Okay, so this is the periodic table there. Now, looking at the periodic table without the pictures there, I think that's probably. I think there is a mistake somewhere on this periodic table. This is supposed to be a TL. Okay, you don't have titanium and titanium here. Okay? That's supposed to be a TL here. And unfortunately, believe it or not, I was trying to search for a good periodic table that I can use in PowerPoint and as well as in the exam information that I want to put in there. Every single one I come up with has some kind of flaw in there. So this one has the least, and the only thing that I figured is that this particular symbol, it's supposed to be a TL, and then it says a TI in there. Yeah. So this is the periodic table. In the periodic table, you can look. We have rows, we have columns. Okay. So how do we organize the elements in the periodic table there? And we have what we call groups and periods. Okay. The groups are the numbered columns. Okay. And we have 18 columns in the periodic table. Now, two different ways to name to number the groups there. We have what we call the group A elements or main group elements, and we have group B elements or transition metal elements. Okay, and this is the notion that we use in many countries, including the United States. Okay, and other part of the world there, and they simply number those columns in numerical order, going from left to right. Group 1, that's the first column on the left. Group 18, that's the last column on the right. Okay? So, and different ways to number those columns there. Now, this is what we are going to use there. And then A group elements are what we call the main group elements. Okay? And B group elements there, those are the transition metal elements. So these terms there, and every time we say main group elements, it refers to group A elements. And going back a couple slides there and just look at this periodic table. Here you see 1A, number 1, 2A, number 2, okay, and 3B, number 3. So the number going in numerical order, numbering the column there, going from 1 through 18, and goes in sequence there from left to right. but 1A and 2A. And the 3A is not in this region. These are actually the group 3 elements there. And 3A starts here and going all the way to 8A. And then, maybe something you notice there, why does 1B start here instead of here? Well, that has something to do with the number of what we call the valence electrons of those elements in here. Okay, so we'll talk about the valence electron in chapter 7, chapter 8, or the later semester. Okay, so that's the structure of the periodic table. So we have groups and periods there. Groups are the number columns, and there are two different ways to number them. And A group elements, and that's main group elements. B group elements is transition metal. Group 8A or group 18, what we call the noble gas or rare gases. So that's something that you do want to pay attention to. And that is a special column. Elements in that group tend to stay by themselves, not reacting with other elements there. That's why we call them noble gas or rare gas elements there. And matter of fact, everyone else in the periodic table, they would want to be like them. How? By giving or taking electrons from one another. Okay, so basically in terms of the chemical reactivity, elements in the periodic table, they will try to either gain electron or lose electron so that they have the same electron configuration as group 8A elements. Okay. And later on in chapter 7, chapter 8, when we're talking about the octet group, meaning each element, when they form atoms of each element there, when they form compound with other atoms there, they try to get as many as 8 electrons whenever possible by either taking electrons from somewhere else or giving electrons out if they have extra electrons there, and or sometimes they have to, when we don't have electrons to satisfy them, when we don't have enough electrons to satisfy each atom with 8 electrons, they have to share. So it's worth noting that group 8A we call noble gas or rare gas elements there. Okay. Now the periods in the periodic table are the horizontal rows. There are only 7 rows in there. Okay. Thank goodness we have one uniform way of labeling those rows there. We don't really label them there. There are 7 rows in there. So the first period, and that's the first row. The 7th period, that's the 7th row from top to bottom. Okay. So groups and periods, and that's how we categorize the different positions of the periodic table in the periodic table there. Okay. So if you look at the groups there, and again, 2 different ways to number the columns there. 1A, 2A, we use the blue color there. Okay, 3A. And these are the main group elements. And group B, those are the transition metal elements there. Okay. And then the significance of the group. Why do we put them, why do we call them a periodic table in the first place? Now the reason for that is because the chemical physical property of those elements repeated itself periodically. That's why we call them periodic table. So the significance of the group, the columns there. Now you have those elements in the same group there. The significance of the group there is that elements in the same group tend to undergo similar type of reactions. So if you know sodium metal will react with chlorine gas, form sodium chloride, and you look at the next element in the same group, potassium will do the same thing. You have potassium metal reacting with chlorine gas, and you end up with potassium chloride. So